Hey, good afternoon, kids. This will be our chapter 4, your atoms and atomic structure. First and foremost, kids, you have a prelude to atoms. Your overall health and susceptibility to disease depends upon the complex interaction between your genetic makeup and environmental exposure, with the outcome difficult to predict. Early detections of biomarkers and cells that indicate an organism's disease, physiological state could allow a diagnosis and treatment before a condition becomes serious or irreversible. Recent studies have shown that your exhaled breath can contain molecules that may be biomarkers for recent exposure to environmental contaminants or for pathological conditions ranging from asthma to lung cancer. Scientists are working developing biomarker for your fingerprints that could be used to diagnose a specific disease based on the amounts and identities of certain molecules found in a patient's exhaled breath or sa ginhawa. Yeah. An essential concept underlying this goal is that a molecule's identity, which is determined by the number of types and atoms it contains and how they are bonded together. In this chapter, kids, ang aton tunan will be describing of the fundamental chemical principles related to the composition of matter, including those central to the concept of molecular identity. Early ideas in atomic theory. The language used in chemistry is seen and heard in many disciplines, ranging from medicine to engineering to forensics and to art. So, kada mo daw kita kids ang application in chemistry as we have discussed in your chapter 1 and 2, the different branches in chemistry ranging from your general chem, quantitative, qualitative chem, biochemistry, forensic chemistry, you have clinical chemistry, and also to your arts. Dumdam ito kasi chemistry, but here, the language of chemistry includes its own vocabulary as well as its own form of shorthand. Chemical symbols, kids, are used to represent your atoms and elements. Chemical formulas depict molecules as well as the composition of compounds. Chemical equations provide information about the quality and quantity of the changes associated with chemical reactions. In this chapter, this will lay the foundation for our language in chemistry. The concepts of this foundation include the atomic theory, the composition and mass of an atom, the variability of the composition of your isotopes, your ion formation, your chemical bonds in ionic and covalent compounds, the types of chemical reactions, and the naming of compounds. We will also introduce one of the most powerful tools for organizing your chemical knowledge, the periodic table. So, atomic theory through the 19th century. Okay, sa aton muni nga chapter, we will be discussing your atoms, the composition and mass of your atom. Ang iyan bala kids nga mga numbers sa babaw kung sa dalom, ang iyang nga symbols ton the bonding of your ionic and covalent compounds, ang chemical reactions naton para mabalaan gid naton kung ano ang language sang chemistry. First, your atomic theory through the 19th century. The earliest recorded discussion of the basic structure of matter comes from your ancient Greek philosophers, the scientists of their day. Ang scientists na una are known as the ancient Greek philosophers. In the 5th century BC, Leucippus and Democritus argued that all matter was composed of small finite particles that they called atomos, a term derived from the Greek word indivisible. Kaya hindi siya mabuka. They thought of atoms as moving particles that differed in shape and size and which they could join together, and which now we commonly call their bonding. Kaya topic sila gan kids. Again, ang aton atoms comes from the Greek word atomos, derived from the term of the Greek word nga atomos, which is indivisible. Una siya, dira na po ang word nga atom. Later, Aristotle and others came to the conclusion that matter consisted of various combinations of the four elements. These are your fire, earth, air, and water, and could be infinitely divided. Interestingly, these philosophers thought about the atoms and the elements as philosophical concepts, but apparently never considered performing experiments to test these ideas. The Aristotelian view of the composition of matter held sway for over 2,000 years until English school teacher, kids ang English school teacher ni John Dalton, helped to revolutionize chemistry with this hypothesis that the behavior of matter could be explained using your atomic theory. Again, sino nagbara sa atomic theory ni si John Dalton. He is an English school teacher that explained the atomic theory. It was first published in 1807. Many of Dalton's hypotheses about the microscopic features of matter are still valid in modern atomic theory. Here are the postulates of Dalton's atomic theory. Kids, ari siya kids ang iya nga atomic theory. 1, 2, and 3, 4, 5. First, sa atomic theory, matter is composed of exceedingly small particles called your atoms. An atom is the smallest unit of an element that can participate in any chemical change. Number 2, an element consists of only one type of atom which has a mass that is characteristic to the element, and it is the same for all atoms of that element. A macroscopic sample of an element contains an incredibly large number of atoms of all which have identical chemical properties. Next, an element consists of only one type of atom which has a mass that is characteristic of the element is the same for all of the atoms. A microscopic sample of an element contains an incredibly large number of atoms, all of which have the same identical chemical properties. So what does this mean, kids? Tanaw natin. You have a comparison of your copper penny. And ano niya ang isang gabilog-bilog sa ano niya. Kids, the comparison shows a pre-1982 copper penny in the left and contains approximately 3 times 10 raised to the power of 22 copper atoms, and each of which has the same chemical properties. Yung sa right, kids, is the property of your pennies. Kita yun yung atoms kani. Your one atom is represented by one penny. Umana siya ang iya copper, kids. Umana siyang bilog, kita ko na da. And each of that has a bonding, and that is the properties of our copper nga ara sa penny. And number 3, atoms of one element differs in properties from atoms of all other elements. So, lain gid na kids ang atom ni oxygen fermi. Lain man na ang atom fermi ni hydrogen. Lain ba na kids si atom ang ara kay nitrogen? Ang kay helium, lain man na, so on and so forth. So, rule number 3 in our atomic theory, one element has different properties from another element. And number 4, a compound consists of atoms of 2 or more elements combined in a small whole number ratio. In a given compound, the number of atoms of each of its elements are always present in the same ratio. So look at figure 2.2. Your copper oxide, a powdery black compound, results from the combination of 2 types of your atoms. Ano yung kasi atoms ang duwang ni? It is your copper and oxygen. It in a 1-to-1 ratio. And that is how your black compound with our powdery black compound, which is our copper and oxygen combination, and that is your copper oxide. Number 5, atoms are neither created nor destroyed during a chemical change, but are instead rearranged to yield substances that are different from those present before the change. Dalton's atomic theory provides a microscopic explanation of the many macroscopic properties of matter that you've learned about. For example, if an element such as copper consists of only one kind of atom, then it cannot be broken down into simpler substances because your copper is a pure element that is into substances composed of fewer types of atoms. But your ano siya kids, if it is a pure element or not. If it is not shown in a periodic table, combined na siya. For example, your copper oxide is copper and oxygen together. So, pwede mo siya break down into simpler substances such as copper and oxygen. And if atoms are neither created nor destroyed during a chemical change, then the total mass of matter present when matter changes from one type to another will always remain constant under the law of conservation of matter, as discussed in our chapter 1. So let us look at our example 2.2.1. This testing Dalton's atomic theory. In the following drawing, the green sphere represents atoms of a certain element. The purple sphere represents an atom of another element. Tangta oxygen isa, tapos hydrogen isa. If the spheres touch, they are part of a single unit of a compound. Thus, the following chemical change represented by these symbols violate any of the ideas in the atomic theory. If so, why? Check ni kids, we have your oxygen and hydrogen. Pag butang mo siya at the products of change, nagamay na lang siya ang aton nga hydrogen, tapos ang aton na oxygen is nagdako. Kids, wala ta may ginakuha dapat sa aton na law. Sa aton, kids, check nyo ang aton nga number 5 sa atomic. Atoms are neither created nor destroyed during a chemical change. Check nyo sa products of change naton, kids. Nga, nagamay si hydrogen naton, kids. Nagamay ang aton hydrogen, kids. Kay tanawan nyo ang number 5 na rule, ang hydrogen naton is dapat hindi naguba siya, kids. Nagamay ang aton hydrogen, tapos nagdako ang aton oxygen. Therefore, ang Dalton's atomic theory naton, kids, has been violated. Our product of change does not confer with our rule number 5. And look at this. So our solution, the starting materials consists of 2 green spheres and 2 purple spheres. The product consists of only 1 green sphere and 1 purple sphere. This violates Dalton's postulate that atoms are neither created nor destroyed during a chemical change but are merely redistributed. So kids, kay ginguba yan yung aton hydrogen and oxygen, therefore sala siya. Because it violates your atomic theory. Next, you have your chemical formulas, kids. So kapag ito formulas, we have 4 types. Check yun di, ang ato na 4 types ang ato na formulas. And what are these? Explain ta ni isa-isa. First, we have a molecular formula is a representation of a molecule that uses chemical symbols to indicate the types of atoms followed by subscripts. To show the number of atoms of each type in the molecule. A subscript is usually only when more than one type of atom of a given type is present. Molecular formulas are also used as abbreviation for the names of your compounds. Tapos naman, we have the structural formula. I-dig deeper ta lang siya, digay-digay. Kids ha, pasunodon ta dari basta. Next, the structural formula for a compound gives the same information as its molecular formula. The types of numbers of atoms in the molecule also shows how the atoms are connected in the molecule. The structural formula for methane contains symbols for 1C and 4H atoms, indicating the number of atoms in the molecules. Figure 1, the lines represent the bonds that hold the atoms together. A chemical bond is an attraction between atoms or ions that holds them together in a molecule or a crystal. We will discuss chemical bonds and see how to predict the arrangement of atoms in a molecule later. For now, simply know that the lines are an indication of how the atoms are connected in a molecule. Next, we have a ball and stick model. Ball and stick model naman kita, we have discussed na structural molecular formula. The ball and stick models naman shows the geographic arrangement of the atoms with atomic sizes, not to scale. And next, lastly, is the space filling model naman natin, kids. Shows the relative sizes of your atoms naman. Your space filling models shows the relative sizes of your atom. So first, let us see molecular formula, ang letter A. Your molecular formula, kids, shows your subscripts and the numbers of atoms. Ari siyang subscript and the number of atoms involved. Kaya kung wala na siya, kids, ang iyang number of atoms type sa iyang molecular formula, hindi na siya makita kung pila siya. For example, the subscript of your hydrogen is 4. That is 4 ka hydrogen. Asa nga ito ng carbon, kaya wala siya, kids, nakabutang sa subscript. Therefore, it is given nga isa lang siya nga carbon. It's either C1 or just carbon. Next, you have your structural formula naman, kids. It represents the bonding of each type of atom represented in your structural formula. So, kids, you have your CH4, ang carbon sa tuwa, because it is the glue behind your atoms. And it has bondings of hydrogen all over from right to left. And that is how your structural formulas work. And next, letter C naman natin is your ball and stick model. Indicates how the atoms are connected in a molecule. And lastly, your space filling model shows the relative sizes of your atoms. Tanawan nyo, sa space filling model naman natin, si carbon, ginatapikan siya sa aton nga hydrogen nga apat ka bilog, mas dako si carbon kaysa sila because the carbon acts as a glue to bond your other atoms together. So, first, basa itong figure 1. Your figure 1, a methane molecule can be represented as a molecular formula. B, a structural formula. Letter C is a ball and stick model. And letter D is a space filling model. Carbon and hydrogens are represented by black and white spheres, respectively. Although many elements consist of discrete individual atoms, some exist as molecules made up of two or more atoms of the element chemically bonded together. For example, most examples of the elements hydrogen, oxygen, and nitrogen are composed of molecules that contains atoms each and thus have the molecules formula of H2O2 and 2 respectively. Other elements commonly found in atomic molecules are fluorine, chlorine, bromine, and iodine. The most common form of the element sulfur is composed of molecules that consist of 8 atoms of sulfur, and its molecular formula is S8. Kaya again, the subscript is 8, kaya 8 kabilog ang atom ng sulfur. And it is represented as follows, letter A. Tapikanay lang ang walo naton ka sulfur in your structural formula. And next, we have your ball and stick model. Ari naman siya. And we have your space filling. That is also another example of how you write your atoms in different formulas. Next, figure 2, a molecule of sulfur is composed of 8 sulfur atoms and is therefore written as S8. It can be represented as a structural formula, a ball and stick model, and a space filling model. Ang siya i-discuss na lang, sulfur naman eh. Sulfur atoms are represented by yellow spheres. It is important to note that a subscript following a symbol and a number in front of a symbol do not represent the same thing. H2, kids, nga ari siyang gamay ni it is the subscript, and 2H represents distinctly different species. H2 is a molecular formula. Ang ini nga gamay ang H2 nga may subscript sa dalom is a molecular formula. Molecular formula ni. It represents a diatomic molecule of hydrogen consisting of 2 atoms of that said element. May duwa ka hydrogen nga atom sa imong nga formula, and that is your molecular formula because it represents a diatomic molecule of hydrogen consisting of 2 atoms that are chemically bonded together. So gitapik ang aton nga hydrogen kag hydrogen when you are representing it in a structural formula na. The expression naman niya nga 2H, lain naman siya. Kids, your 2H. Wala siya subscript na unang number 2 kaysa sa H. On the other, it indicates 2 hydrogen atoms that are not combined as a unit, meaning wala sila gatapikanay unlike our molecular formula natin dire kagina. Diba gatapikanay, they are bonded. 2H is not connected because they are separated hydrogen atoms that are not combined as a unit. The expression 2H represents 2 molecules of just your hydrogen atoms. So, duwa lang gid ni sila ka H. Bonded sila? Hindi. Hindi. Pero may duwa ka lang ka hydrogen. Hindi sila bonded together. And that is the difference between a H2 subscript and a 2H. Ang ini bonded together. Ang ini hindi bonded together. So, look at this. You have your 1H atom. Look at this. Check your figure 3. You have 1H atom, kids. Kung maghambal kita nga 2H, hindi sila bonded together. If maghambal ta H2 nga may subscript, bonded siya together. And magka 2 H2 molecules, mayara siya sang duwa ka hydrogen nga atoms nga bonded together pero separately kay 2H2 sa. Kay kung mag H4 ni siya ya, natural matapikan na ya ang aton apat ka hydrogen molecule. But kay gin-separate ya nag 2H2 siya, check nyo. Nagtapik na siya tag duwa-duwa. And that is the difference of a molecular formula from a diatomic molecule of 2H. Your figure 3, the symbols of H2H, H2, and 2H represents very different entities. Compounds are formed when two or more, ang ginadiscuss na yung picture ha. Compounds are formed when two or more elements chemically combined, resulting in the formation of bonds. For example, hydrogen and oxygen can react to form water, and sodium and chlorine can react to form table salt. We sometimes describe the composition of these compounds with an empirical formula. An empirical formula, ano ni siya ang empirical formula? It indicates the types of atoms present and the simplest whole number ratio of the number of atoms in the compound. Again, anong pulos sa aton empirical formula? Ano ni ang iyang description? It indicates the types of atoms present and the simplest whole number ratio of the numbers of atoms in that said compound. And that is your empirical formula. Gina-indicate niya kung meron ka hydrogen, meron ka oxygen, and it simplifies it to the simplest whole number ratio of the number of your atoms, and that is your empirical formula. An example of this is your check ang ato na titanium 4 oxide used as a pigment in a white paint in the thick and white blocking types. Has an empirical formula of TiO2. Isa ka titanium 4 and kadayon sang duwa ka oxygen or O2. This identifies the element titanium 4 and oxygen as the constituents of your titanium 4 oxide and indicates the presence of twice as many atoms of the element oxygen as atoms in the element of titanium. Because kids, simplify lang siya naton, meaning isang TiO2, mayara kita sang mas twice as many oxygen kaysa sa titanium. As look at your figure 4, the white compound titanium 4 oxide provides effective protection against the sun. Naging sunscreen siya. A crystal of titanium 4 oxide or TiO2 contains titanium and oxygen in a ratio of 1:2. Sa kada isa ka titanium naton may duwata ka oxygen because gingamit naton ang empirical formula. It contains titanium and oxygen in a ratio of 1:2. The titanium atoms are gray and the oxygen atoms are red. Kay kada may isa taga ka titanium, may duwata ka oxygen. As discussed previously, we can describe a compound with a molecular formula in which the subscripts indicate the actual number of atoms of each element in a molecule of the compound. In many cases, the molecular formula of a substance is derived from the experimental determination of both its empirical formula and its molecular mass. Sum of atomic masses for all atoms composing the molecule. For example, it can be determined experimentally that benzene contains two elements of carbon and hydrogen, and that for every atom in your benzene, there is one hydrogen atom. Thus, the empirical formula naman sa aton na carbon and hydrogen is therefore CH. An experimental determination of the molecular mass reveals that a molecule benzene contains 6 carbon atoms and 6 hydrogen atoms. So, the molecular naman sa aton na benzene, molecular formula is C6H6. Look at your figure 5.5, kids. Benzene C6H6 naton is represented by different formulas ranging from your structural formula, ball and stick model, space filling model, and a benzene as a clear liquid ang ginagamit natin physically. If we know a compound formula, we can easily determine its empirical formula. C6H6 nga molecular formula, kay balaan na natin, kids. ang iyang molecular formula, we can easily determine na ang iyang empirical formula. The reverse corollary is generally followed by an actual practice. For example, the molecular formula for your acetic acid, the compound that gives vinegar a sharp taste, is C2H4O2. This formula indicates that a molecule of acetic acid contains 2 carbon atoms and 4 hydrogen atoms and 2 oxygen. The ratio of atoms is 2:4:2. Dividing by the lowest common denominator of 2 gives the simplest whole number ratio of 1:1. So, the empirical formula is CH2O2. And tanawan natin ang aton na C6H6 or your benzene. Kids, you have a subscript of 6 in both your carbon and hydrogen. What do you think is the empirical formula? It is simply CH because the ratio is 1:1. Ato na vinegar naman yung kids or your C2H4O2. Kay meron kita sang 4. Gingamit tayo a common denominator which is 2. 4 divided by 2 is 2. Tapos ang 2 ka 2 divided by 2. Divided by 2 is 1. Because you use your denominator. Simple, and amo na pagkuha natin sa simplest whole number ratio niya nga 1:2:1. So the empirical formula is CH2O. Note that a molecular formula is always a whole number multiple of an empirical formula. For figure 6 natin, the vinegar contains C2H4O2 which has the empirical formula CH2O. It can be represented as a structural formula and as a ball and stick model. And if you predict that another compound with a formula of C2H4O2 could exist, then you demonstrated a good chemical insight and are correct. Because 2 C atoms and 4 H atoms and 2 O atoms can also be arranged to form your methyl formate, another type of chemical which is used in manufacturing your insecticides for quick drying finishes. Metal formate molecules have one of the oxygen atoms between 2 carbon atoms differing from the arrangement of your acetic acid molecules. Acetic acid and metal formate are examples of your isomers, compounds with the same chemical formula but different molecular structures. Note that this small difference in the arrangement of atoms has a major effect. Again, yung rearrange lang ang C2H4O2 natin. But this rearrangement can have different molecular structures based on their arrangement and their chemical properties. You would certainly not want to use any solution of metal formate as a substitute for a solution of your acetic acid or your vinegar when you make your salad dressing because kids, ang acetic acid is pwede natin ma-consume but your methyl formate cannot be consumed. Kaya again, delikado na yan sa aton lawas. Check nyo. Pareho lang sa kids. Pareho sa nga C2H4O2. But its structure and how it was arranged is different. Ang carbon nato ni isa diya, gintapik lang sa babaw. Sa letter B, and diya kids, balance ang inyong carbon sa acetic acid. Because it has different arrangements, you now have an acetic acid in your structure A and metal formate naman naton is of a different structural formula. Because figure 8 molecules of acetic acid and metal are structural isomers. They have the same formula but different structures. And that is now known as a structural isomer. So many types of isomers exist. Acetic acid and metal formate are structural isomers. This is an example of a structural isomer. They have different structural formulas but the same molecular formula. Pareho lang molecular formula. So as you can see, kids, ang ato na structural isomers are compounds that differ in how their atoms are connected to each other but they have the same, again, molecular formula. Ang ilang pag-connect sa iya structural formula is the difference. There are also various types of spatial isomer in which the relative orientation of the atoms in space can be different. For example, the compound of carbone found in caraway seeds and spearmint and mandarin orange peels consists of 2 isomers that are mirror images of each other. S plus carbon smells like caraway and R minus carbon smells like spearmint. As you can see, kids, ilan naman yung spatial isomers. The space-oriented naman nila is lain. Ito naman yung carbon sangaton nga spearmint smell, kag sangaton nga caraway smell. O an S plus and ang R negative ng carbon. Ang iyang bako is spearmint kag caraway. Check to be. Kay nga gabaliskad lang ang iyang structural formula. Ang isa nagapatuo, kids, ang isa gapa wala, naka-reverse. Kids, and look at their spatial isomers. Ang iyang space orientation ng gidya kids ang naglain. Pareho man Japon kids, tanawan nyo ba ang iyang arrangement is the same but baliskad. Ang isa kids nagatuo lang, ang isa nagawala. And that kids nga organization sa inyong spatial isomers can cause a different smell and a different result. Because in figure 9, molecules of carbon are spatial isomers. They only differ in the relative orientations of the atoms in space. And that is a spatial isomer. So the key concepts and summary naman niya, a molecular formula uses chemical symbols and subscripts indicate the exact numbers of different atoms in a molecule or compound. An empirical formula gives the simplest whole number ratio of atoms in a compound. And a structural formula, naman natin niya kids, indicates the bonding arrangement of the atoms in the molecule. Ball and stick naman kids in space-filling model showed the geometric arrangement of atoms in a molecule, and isomers are compounds naman with the same molecular formula but different arrangement of atoms because isomers have distinct differences but pareho lang gid ang ila kids ya nga molecular formula, and that will be all kids sa aton na empirical formula. Thank you for listening, kids, and have a good day.